Hi everybody, please make sure you're masked up. Oh, wait a minute, I'm sorry. Forget about that. Yes, I really do have a goatee. Hi, I'm Professor Alan Adams, and here we are in section 02 of Business 325, and today I'm going to cover our homework. I asked you all to do problems 8, 12 through 16, and one that I posted on Canvas, one additional problem. We'll get to all of these, okay? So please make sure that you are ready to record this and add this to your study guides, okay? So the first thing I'm going to do is call up an Excel spreadsheet here. This is where we'll place all of our solutions today, and as you can see in green there, that you may scroll to the bottom to see proofs of today's work, okay? The very first thing we're going to do, and I've called up all 4 of our time value of money sheets here to refer to as we go. All right. One of my points here is to show you how easy it is if you understand how to use these sheets. So in problem 8, we have a gentleman who buys a baseball card, $2,000, and he wants that card to increase. He expects that card to increase in value by 20% per year for the next 5 years. Then after that, this is a 2-stage problem. He thinks it will increase 15% per year after that for 3 more years. This ambitious person thinks that this card will have a very high value after 8 years. What will it be? Okay, we ask ourselves those famous 2 questions from my lecture. First of all, are we moving forward or backward in time? We're clearly moving forward. He's trying to find out how much this card is worth in the future. Okay, so we've narrowed it down to tables 1 or 3. Secondly, is it a one-shot deal or a repeated series of payments, an annuity? He's only buying 1 card. It's 1 shot only. We can solve this, therefore, friends, by going to table number 1. Okay, so what we're going to do is type in all the facts here. We're going to say, well, now we've got to do this in 2 stages, right? Because it's going to grow at 1 interest rate for 5 years, and then another interest rate for 3 years. So in both cases, we're dealing with $2,000, and we have to multiply that by some factor. That factor is going to include 20% per year, okay? And that's going to be for the next 5 years. Okay, so we have to go look a factor up from table number 1. Let's go do that together. Here it is right here. 20% for 5 years means we come way over here. 20%, there it is, 1, 2, 3, 4, 5 years, and the factor is 2.4883. Okay, and I'm going to put more decimal places on that. All right, and then secondly, once we get to the end of that first 5-year period, now we have to say whatever value we have at that point, we don't know what it is yet. Don't use $2,000, that's gone, okay? We grew it from 2,000 to something at the end of 5 years. Now we take that number, and our friend here is going to invest it for, 3 more years at 15%, okay? So we go look that number up. 15%, it's there in that column, 15%, table number 1. 1.5209 is our factor. Okay? That's it. Now what we do is we use those factors. Let's go do that. I'm going to give myself a couple of extra lines here. Okay, so step 1 is going to say, what does our $2,000 grow to? All right, we multiply $2,000 times 2.4483. I think that was our number. I will check all these numbers before I post them, by the way, friends. Okay, so let's take that number and say, what does that equal to? And now let's do the math. All right. I'm going to give you proofs of many of these problems at the bottom of today's sheet, as you can see. All right, so I'm going to take this, I'm going to neaten it up by getting rid of those lines and centering everything like that. And most importantly, I'm going to give us 2 decimal places because here we're dealing in dollars and cents. All right, what does this tell us? This tells us, step 1 of the solution tells us that our $2,000 should have grown to $4,896.60 at the end of 5 years. Again, I will check this math for you before I post this video. Now we take that number and say, now we're going to focus on that and grow it for 3 more years. 4,896.60. We're going to multiply that times, what was the next factor we looked up? 15% for 3 more years. We said it was 1.5209. Okay, so let's grow that number. Let me clean this up a little bit for you here. And 4,896.60 times 1.5209 means that number will grow to 7,447.24. Okay, that is our solution. That's our answer. If this man's forecast is accurate, he can grow it at 20% after buying it for $2,000. If he can grow it for 5 years at 20%, it'll be worth $48.96.60. Then he takes that card and grows it for 3 more years at 15%. It should be worth $7,447.24. Okay? The next problem I asked you all to do was problem number 12. Okay, let's see what we have. All right, let's assume that your cousin has invested $100,000 10 years ago, 12%. Oh, we already know how to do this. That's a million. I'm sorry. I put one too many zeros in there. I got aggressive. Let's try that again. Okay. Now, we know how to do this from our quiz last week, 2 weeks ago, I should say. But in this case, there's one little wrinkle I've put in there. Always look for this. It says compounded quarterly. All right, that's the important word right there. That means before you use table number 1, why would I use table number 1? Well, because we're moving forward in time, and because he invested once and once only. We know it's table number 1. Now, before we use it, however, we have to do 2 pieces of surgery on it. Quarterly, that means 4 times a year. We do 2 things to table number 1 before we use it. We divide the interest rate by 4, and we multiply the periods by 4. All right, so first divide the interest rate. 12% divided by 4 means we're going to use 3%. And the amount of time is 10 years, but with 4 quarters being in a year, that means our interest will compound 4 times a year. 4 times 10 years is 40 times. So we're going to say 40 periods, or 40 quarters, whatever you'd like to call it. So we're going to use table number 1 just like we've done before, but first we have to make sure we change the column and the row that we use. Okay? All right, very good. So let's go back to the table. 3% for 40 periods. And let's see what we get. It's going to be in that column. Scroll down until we get to 40 periods. The magic number is 3.2620. Okay? That's all there is to it, friends. Make sure you use the table just like before, but change the number in the column and the row before you use it. Why? Because I told you it was quarterly. I could have said semi-annually. I could have said monthly. So now we know that this is going to be $100,000 multiplied by 3.2620, or $326,000. And that's it. That's our answer. Once again, scroll way down here, and I'll show you a few proofs. Okay? Now, I just saw that one proof is off, so I will fix that for you before I post this. Okay? All right. I see what my problem was right there. I see that I should have used... Let me fix it right now. All right. 2.4883. See what I did wrong? I used 2.4483. I'm going to fix that for you right here. I beg your pardon. Let's fix that over here too. Okay. 4883. Sorry about that. 497,660. There's a little rounding difference there. And then I'm going to take that same number, 497,660, and I'll fix that. Okay, so we all make mistakes. $75.68.91 is the correct answer. 75.68. Okay. So I'm glad I caught that for you before you started studying this, but again, please make sure you add this to your study guides. I apologize for that error. Okay, and I'm going to save this before I go on. Okay, and this will of course be posted to Canvas. Next we do problem number 13, and let's see what we have. Problem 13 says, what is the difference if you compound annually, semi-annually, or quarterly? Okay. Again, this is more practice. We need to know an amount. We need to know that we're dealing with $3,000 and 8%. Okay? The difference is we're going to do it annually. We already know how to do that. That's a piece of cake. We're going to do it semi-annually, and we'll do it quarterly. Semi-annual, of course, is twice a year. Quarterly is 4 times a year. That means we know how to do this already if it's annual. We simply go to table number 1 and look up 8% for how many years? End of 5 years, okay? Let's add that right to here. Very good. So we know our amount, we know our interest rate, we know our time. All we need to know is it going to compound more often than a year? You know, the more often it compounds, the larger it gets. So we're going to start with what we already know. We're going to go to table number 1 because we're moving into the future and it's a one-time amount only. And we say 8% for 5 years gives us 1.4693 multiplied by what? By our $3,000. Now we say, what if it happens semi-annually? There are 2 semi-annual periods in a year, so instead of 8% for 5 years, divide the rate by 2, multiply the time by 2, and we would use 4% for 10 years. 4%, 10 years, hold on. Looks like our number is 1.4802. We multiply that by 3,000. Now we know it's going to be a bigger number because we're compounding more often. We multiply interest on interest more often. Finally, we go to quarterly. 8% for 5 years, if you do it quarterly, 4 times a year, that would be 2% times 20 years. 2%, 20 years, 1.4859. Multiply that by 3,000. Once you get used to this, friends, I challenge you to tell me this is difficult. So in all 3 cases, I'm going to take the factor I looked up on table number 1 and place it here. 3,000 times 1.4802, and finally 3,000 times 1.4859. You should be saying to yourself by now, hey, this guy's fast. Yeah, but I've been doing this a lot of years. What do we conclude from this, friends? Look at the numbers. The more often you compound, the larger the result you'll end up with. If you're an investor, you should look to compound more often. If you're a borrower, please remember that the bank is going to be making a lot more money from you. Okay? All right, I will save this. And let's go on to problem number 14. And let's see what we've got. I love this problem. I will not ask you a problem of this complexity on a quiz. But if you know how to solve a problem like this, you really understand compounding, ladies and gentlemen. All right? So break it down. Every time you see a problem like this in any math area, really, you should break it down into its component pieces. First of all, this is a two-step problem. Okay? So we have a woman starting a paper route. She's going to earn some money on January 1, 2024. And every 3 months, she's going to save and save and save all the money she makes. And when she gets $300, she's going to run to her local bank and deposit it every quarter. That means 4 times a year, right? And it's always the same amount. Now, isn't that an annuity? Yes, it is. So she has, for the first several years, an annuity at $300 a month. I'm sorry, $300 a quarter. I apologize. She's going to place it in her bank account. It's going to make her 8% per year. I always give you annual rates, right? Okay. And she's going to do that for how many years? Be careful. This is where people screw this problem up consistently. You start on January 1 of 2004. You finish on December 31st of 2007. How many years is that? A lot of people say 2007 minus 2004, that's 3 years. No, it's not. Because she began on January 1st of the first year, ended on the last day of the last year. That's 4 years, isn't it? 2004, 5, 6, and 7. So this woman's money is going to be multiplied over 4 years each quarter. Careful. Okay? So I'm going to say for 4 years. But it is by quarter. Okay? So I'm going to say, therefore, 8%, that's going to be 2% per year. I'm sorry, 2% per quarter. For how many periods? 4 years, 4 quarters a year. That's going to be 16 quarters, 16 periods, whatever you want to call it. That is step 1 of the problem. Let's see what she gets. Okay, I'm going to save this and we're going to run over to table number, hold on. Having some trouble here. Table number 3, future value of an ordinary annuity. There it is. Okay, so what we do is we look up 2%, 16 quarters, 2%, 16 periods. I saw it there a moment ago. It is 18.6393. What do you multiply it by? 1 payment. Every time this woman deposits something, it's $300. How much money, therefore, after 4 years will she have? She will have 300 times 18.6393. She will have $5,591.79. That's step 1. But now let's look back at the problem again. Now, on December 31st of 2007, let's call it January 1 of 2008, okay? She is going to use the entire balance she's accumulated to put into a beautiful investment she's found at 12%. The question says, how much will she have 3 years later? Okay, her money will make money for all of 2008, 2009, 2010. No more quarters now, okay? This is an annual rate. One-shot investment, what does that tell you? It tells you to use table number 1. Okay, so we come to table number 1, 12%, 3 years. Let's see what we get. There it is, 12%, 3 years, 1.4049. What did we multiply that by? We multiply it by how much money she has at the end of the first 4 years. She doesn't have $300 to worry about anymore. She has amassed $5,591.79. Okay? And let me blow that up for you. We've got a formatting problem here. Bear with me 1 second. There it is. And let's see what our result is. 559179 multiplied by the factor from table 1.4049, and she has accumulated 7,855.91, and that is the answer to the problem. So this problem, I love it. I won't ask you to do one like this on our quizzes, but if you can do this, you really have drilled down into the essence of time value of money calculations, because we involve the use of two tables, one for an annuity, one for a single amount. Both of them future value. The first one was for an annuity, and the second was for a single amount. Okay, so we're always keeping track of how our money grows. All right, I hope you're all with me. Now we go to problem 15. Now at the end of the chapter, we dealt with solving for other variables. I've asked you to do future value calcs. I've asked you to do present value calcs. But within all of those numbers, algebraically, there are other factors. The interest rate, the time, and the amount of a payment. And those are all real-life examples of things you might have to solve for. Okay? So now let's take our friend in the math department, my buddy Madani, and he has a newborn child, and he decides he has a sudden windfall of $8,760. And he said, oh, I know what I'll do with it. I'll put that in a fund for his college right now because I have a chance to lock in a rate. He has to know what that rate is. His son will be ready for it 17 years from now, college entry age, right? So we know how much we're starting with. He wants to have $60,000. That's his budgeted amount. So we know a present value and a future value. What we don't know is the interest rate. We know the time at 17 years. You can't solve for both the rate and the time. So I've got to give you one of them, and I have. I've told you that he starts, the present value is $8,760. Let's try that again. I've told you that the future value is $60,000. That's how much he wants in the future. And I've told you that the time involved is 17 years. All we have to do is figure out what is the rate. Okay, this is a great example of plug and play, because now you know I've got a single amount. It's a single amount, and I'm trying to figure out how it's going to grow into the future. So we're going to use table number 1. Okay? The formula behind table number 1 is, as we all know by now, this. Okay? To find a future value, we take the present value and multiply it by some FVIF from table number 1. So, algebraically, plug in what you do know. Now, we have to solve this in 2 steps, as I told you last week. First, we find what the FVIF, the missing amount, is. Secondly, knowing one of the factors, rate or time, we go to the table and figure out, like a roadmap, where the missing number leads us. Let's plug in what we know. The future value is 60 grand. The present value today, Madani is investing $8,760, and we multiply that by the FVIF. That's our unknown. The FVIF, use your algebra, divide both sides by $8,760, and that means to find the number, we do that. Okay? The FVIF, therefore, is going to be, hold on please, $60,000 divided by $8,760. It's going to be, I'm going to put 4 decimal places on that because we're accustomed to 4 in our tables, aren't we now? So the FVIF is 6.8493. Very good. That is going to lead us, once we open table number 1, to the missing number. We know that that 6.8493 is a combination of a rate and time. You've got to know one to find the other. In this case, I've told you, it's 17 years. Okay, go to table number 1. Go to, let me see, 17 years. And now what you're going to do, friends, is you're going to lay a ruler across that row and scroll across, use your finger or whatever, and you're going to look for the number that comes closest to 6.8493. All right, that one's too small, that one's too big, and like Goldilocks and the Three Bears, that one's just right, 6.8660. Our answer, therefore, friends, just look up here, is approximately 12%. I'm going to type that in here. That's our answer. It's that easy. Is it exact? Of course it's not exact. I'm going to ask you what the approximate value is. Okay? Very good. If you want to know the exact amount, I've got a way to do that too, but that's outside of the scope of this course, so let's not worry about that quite now. All right. Next, we're getting there, friends. We have 2 more to go. We're going to do problem number 16, and let's see what we've got. All right, here we are. We have a gentleman who has reached retirement age, and he has accumulated a pension fund. He saved money through his company. So now he's ready to retire, and the manager of the company says, you have $200,000. Okay, let's write it down. Always write down the facts as we go. Okay? His life expectancy is 16 more years. That's a little morbid, but there are insurance professionals who specialize in doing this. They tell you, our best guess is that you have 15, 16, 20, 25 more years to live. Therefore, when we charge you an insurance premium, here's how much you have to pay. If I buy life insurance and you buy life insurance, at your age you'll probably pay less. Why? Because you represent less risk to the insurance company. I represent more risk. They will judge our insurance premiums based on that risk. Do you drive and get a lot more tickets than I do? Then for auto insurance you would pay more. I would pay less. That's how insurance works. Those wonderful folks are called actuaries, by the way, and it sounds morbid, but they're going to gamble on how many more years this gentleman, Alexander, has to live. All right? In this case, they're saying, we want your pension to last you 16 more years. All right. However, his investment manager says, we think that you're going to continue to make 12% on whatever is left in that fund. Alexander wants to know, what is my annual payment that I can draw? That's the question we're asking here. Break the problem down, friends, and you're going to see that I've given you what you need. I've given you an amount, I've given you time, I've given you a rate. Now what table do I use to find the payment? I want a regular payment of a series of regular payments. That's an annuity. Okay? So I know it's going to be table 3 or 4. Secondly, when you solve a problem like this, trying to find a payment, I can almost guarantee you'll use table number 4. How come? Because you know exactly what you got today. You know how much you have today. You know how much you're borrowing today. So when you're trying to find a payment in a stream of payments, we'll usually use table number 4. Let's go use it. Okay, 12% for 16 years. Let's go look it up. Hold on, please. This is table number 4. All right, 16 years, it will be in this column. And we scroll across until we find 12%. There it is. 6.9740. Okay? That's my factor. What do I do with that factor? Well, friends, what is the formula behind table number 4? To find the present value of an annuity, you take one payment and multiply it by the PVIFA. Plug and play. I know what my PVA is. How much do I have today? It's $200,000. What is my payment? I don't know. That's what I'm trying to find out. But I now know what my PVIFA is. It is 6.9740. It's not hard, is it? This is how you find your car loan payment, your mortgage payment. In this case, Alexandra's payout. Very good. So what I do is I have to divide. I want to get all my like variables on the same side of that equal sign. So I divide both sides by 6.974. Let's do that. $200,000 divided by 6.9740 is going to give me the amount of my payment. That's what I'm looking for. So my payment, therefore, is going to equal $28,677.95. That's your answer. All right? Alexander can take out $28,677.95. He starts with $200,000. It earns 12%. It goes up. But then he takes out $29,000, comes down. But he's still got something left. Up, down, up, down. By the time he takes out his 16th payment, let's go down here and look at our proof. When he takes out his very last payment, the fund is dead. It has done its job. All right? Study the proofs after you have tried this. Don't you dare cheat by going down and looking at the proofs first. I'll never forgive you, okay? So try them first. Okay? Fair enough. Let me save this, and at long last, we come to our last problem. I posted this on Canvas. You buy a piece of land. Now, I asked you to find the interest rate. I asked you to find the payment. The only thing I haven't asked you to do, and I apologize for not including this in the book, is find the time. Okay? So you buy a piece of land for $40,000. You think you're going to sell it when it hits $104,000. The discount rate you use, you've got to have a rate, is 10%. And you want to say to yourself, how many years will it take me? Okay, well, we've done this before. What we're going to do is we're going to solve it with the same technique we did before. The future value is equal to the present value multiplied by the FVIF. Okay, we know what the future value is. I gave it to you. I know what you started with. Let's call that the present value. Step 1 means find the FVIF. Secondly, like when we found Madani's rate, we're then going to go to table 1 and use it like a roadmap to find our answer. All right. So to find the FVIF, we divide both sides by $40,000, and that leaves us with this. Let's see what our answer is. 2.60. All right, that's only step 1. That's not our answer. Now we go to table number 1 and use that. I have to give you the time or the rate, one of them. In this case, I have given you the rate, 10%. Go to table number 1 and say, my answer is in this column. Scroll down that column until you find the number that's closest to 2.6, and it looks like it's that number right there, 2.5937. That number's too small, that number's too big. I think that's the closest one, 2.5937. How many years is that? It looks like the answer is 10 years. And we're done. All right. I hope that you have found that helpful. And any questions, please make sure you get to me. Okay? Take care. Have a good weekend. Stay safe. Bye-bye.